Alright, so today I will be talking about Qt Enterprise Embedded. Maybe you've heard of it under the name Boot to Qt, but now it's known as Qt Enterprise Embedded. So, start with a short introduction about who I am for those of you who aren't familiar with me. My name is Nichols, and again, I'm a software engineer at Digia. As far as my community name goes, I'm usually referred to as Nichols. You'll see me on the Freenode IRC channel as well as Twitter under that same handle. So to give a short overview of what we'll be talking about today, I'll explain what Qt Enterprise Embedded is. Then I'll discuss a bit about the operating system choice you have, because you do have a bit of selection there. And then I'll go over a complete demonstration of how to get this installed, how easy it is to get it up on the device, and then how to run your software on both our reference hardware device as well as the emulator that we have. And then I'll finish off with an actual demo, like show you a little bit of code and how it actually works on this device for a real-world use case. So what is Qt Enterprise Embedded? Qt Enterprise Embedded is a product that we've come up with at Digia to make embedded development easier. One of the biggest things we noticed when we started to look at, or when we were getting feedback from our customers on embedded development, is that the hardest part is actually getting started. Qt makes it incredibly easy to actually write your applications in a cross-platform manner, but actually getting that software to run on your hardware when you're getting into device creation it's incredibly complicated. One of the things I'll be talking about in tomorrow's talk, or my talk tomorrow, is how you actually set this stuff up manually. But it is quite an involved process that involves a lot of prior knowledge. So what we do is actually give you the full package. We give you everything you need to get started. I'll go further into that. So the first thing that Qt Enterprise Embedded is it's a lightweight UI stack. The middleware stack in Boot to Qt, or Qt Enterprise Embedded, is actually Qt5 itself. So all of the APIs we have available in Qt are available there on this embedded device, and when you write your application, everything is just linking and calling into these APIs. And so you don't have to worry about building up the stack yourself for the most part, unless you have some kind of specialized third-party need. So you can see here in the example, or in this diagram, how we've actually architected this for our platform. And you can see here where we have this choice between OSs. We have this embedded Android and embedded Linux. And embedded Android is just a term for standard Android without Dalvik. It's not actually using any Java, any of the, it doesn't have compatibility with Android apps themselves in the same way that, say, you would on your phone, TV. But instead, we leverage the base layer of Android. You'll get to use the drivers for the devices, the same ones that your phone would be using, the graphics drivers that are already available there. But you'll be able to run Qt on top of that instead of as running a native Android application, which we also offer. But in this case, you're actually booting up your Android device into your Qt application as opposed to the Dalvik stack itself. On the embedded Linux side, this is just a very base layer distro with the minimal packages needed to actually run all of the things in Qt5, and the same thing applies there. So one of the things that we do is we actually provide you with a starter image, a ready-made image to actually flash to reference hardware. So if your device takes an SD card, then we'll give you an SD card image. If you need to flash it, then we'll give you a flashing image. It also comes with a full Qt Creator integration. So that means that once you've installed this stuff, you boot up Creator, And then for you as the developer, you shouldn't have to worry about configuring creator or going into the command line and like manually copying files over to your device each time you change something. What we enable you to do is actually write your program in creator like you would on the desktop, but when you hit play, it shows up on your device. So it takes care of all of the messy work of copying the files over and actually executing them in the right environment. And for those of you who don't have access to the hardware yet, we actually provide an emulator as well that I guess if you've developed for the other mobile platforms, this is one of the convenient things of, say, for iOS or Android, you'll have an emulator if you don't actually have access to certain hardware. So we'll provide that as well. Overall, though, our goal is embedded development from day one. We want to enable you to get started immediately and not spend a month, 2 months just monkeying around with the tool chain, the sysroot, learning what those things even actually mean. Just to get a basic prototype or something running on your device, you can do it. You can start in the morning and then by lunchtime actually have maybe our launch screen on, and then after lunch you're able to actually run the software yourself, your own software. So, as I mentioned, you have a couple of choices for the actual OS, and I kind of briefly alluded to the fact that there are some pros and cons of each one. So I'll go a little bit more into detail about what that actually means. The embedded Android offering that we have, it has a couple of really good benefits. The one I mentioned earlier was the actual, you're able to actually use the graphics drivers and any other drivers available on the device as it was productized previously. So if you took some existing hardware, say a Nexus phone or a tablet or something like that, if you're just prototyping, say, you'd actually be able to use those same drivers, both graphics, wireless, whatever that was working on that phone when they productized it for being a phone. You'll be able to use those same things in your product without worrying about the quality being less than ideal, like you kind of see on embedded Linux. What we also see is that when device manufacturers are actually making the drivers for their hardware, they're actually doing Android first, because many of their customers are actually intending to use that hardware as an Android device, whether that be a phone, tablet, TV. So they're doing the drivers there first, and then if they have time, they'll do Linux in the end. So you'll get a better quality driver in many cases using Android. And then you'll be able to use everything all the work that's been done with Android, but then lock down the system in a way, or you'll have the security of knowing that when your system boots up, that the user's not going to find some kind of way to close your Android app and maybe potentially uninstall it. We don't give you, or since we've removed all of the Java software on top that's actually using Dalvik, you don't even have to worry about it booting up to a home screen and with settings and just the standard Android stuff itself. You actually just boot the kernel, and after that, a few services are loaded to give you network, and then your Qt app actually starts. And that is the system. So anything you want it to do, you need to actually implement. But in many cases with embedded devices, that's what you want anyway. And again, since you're not running the Dalvik stack, then everything's native, everything's Qt. So you'll get you'll be able to squeeze every last bit of performance out of that hardware. A couple of issues, though, that you want to keep in mind when looking at embedded Android that come with these benefits is that Android's actually using the Ionic libc, which is it's a bit limited compared to the standard C that we would be using on embedded Linux. There's problems with exception handling, and there's a few other issues that tend to make it problematic, at least for Qt. And that actually leads to a truncated set of supported modules. So I'll list that in a little bit in detail on the next slide. The other problem is that you'll actually, well, this may or may not be a problem, but you'll actually have to use the NDK, the official Google NDK, to build any third-party libraries that you need in addition to Qt. So if you're just using Qt, this isn't a problem at all. But in many cases, you do have a third-party dependency, maybe an additional device driver or something like that, but you actually have to build that with the native NDK. So here are the supported modules for the Android module. We have the general things that we support anyway, the Qt Core, Qt GUI network, widgets, and XML. We also have full support for the new Qt QML and Qt Quick, as well as the controls and the graphical effects. We recently added the serial port support, as well as support for sensors and Qt Multimedia, so you can do multimedia playback. What we don't have available is, for Android, is WebKit. So that's something that's not available right now, or I don't think WebKit will ever be available, but the new WebEngine stuff will be available for embedded Android. I think there may be a tech preview now, but it is something we plan on supporting. And also mentioned that we have reference hardware. So this isn't the only places that stuff is supported, but these are the devices that we have ready-made images for that you could actually go out and buy these and download our stuff, and then you'll be able to start iterating your embedded prototype or product right away. So the three devices we have for embedded Android is the A.K.A, which is a Freescale device, so that's what I'll be showing today. We have the BeagleBoard XM, which is a Texas Instruments device. And we also have the Nexus 7. Right now that's just the second generation Nexus 7. I think, I can't remember what year that is. It's not the latest iteration. I think in the next version we'll actually have support for that new version, but it's actually the Tegra edition of the Nexus 7. And the idea behind the reference hardware is that we want to find hardware that's easy to access, not some exotic hardware, something that represents the kinds of hardware that people are actually deploying to in the end, but be consumer testing hardware. So the idea being that you can start prototyping your device immediately on this, and then when you want to move to your productized hardware, if you're using something that kind of reflects, like if you're building against a Freescale IMX6 here, and you're going to be on a Freescale device later, then that's a common path to see. So the next thing is talk about some of the benefits of using embedded Linux instead, since you have this choice. On embedded Linux, we actually support all Qt 5.1 modules. We've only released 5.1 so far, but it's the next version of Qt Embedded Enterprise will actually support 5.2, which is the most current released version. The other thing is that with embedded Linux, we actually support Qt WebKit right now as well. So if you wanted to use WebKit, you can use WebKit. And Qt WebEngine, the new web support, will also be available on Qt or Qt Embedded Enterprise embedded Linux. This uses as much as you could say, standard embedded Linux distro. It's just not unusual. It's a very minimal software base layer. And then we use Yocto and Aki, the similar thing that many embedded Linux projects use as a base layer. And then there's no funny business with actually building your software. You don't need the NDK. You just use any of the third-party libraries that are actually available in the sysroot already. So again, these will be very standard things that you see everywhere on embedded Linux. And you have the possibility of adding additional dependencies if you need them. We also have we have a little bit more reference hardware for embedded Linux. So here we also support the BeagleBoard XM, which again is a TI device, and the IMX6. We have, in addition, the Raspberry Pi. I have the BeagleBone listed. I don't think we have the image available in the current release, but I know that it's working in the soon-to-be-released version of Boot to Qt. And we also have an image available for the Citara board. This is a lower-end Texas Instruments device. All right, so that's a very I guess, high-level overview of what it actually is, but it makes a lot more sense when I actually show you how this actually works. So what we'll do is we'll actually take a look at this boot, or Qt Embedded Enterprise distro itself. So hopefully you can, oops, take it out of. So you can kind of see it. It's a very small screen. So what I'm actually running here is this IMX6 board. Kind of see it here. And I just have run the Qt Embedded Enterprise demo launcher. So if you actually come to the Digia stand between events, you can actually see these in person. But basically what we show here is a launcher that shows the applications, or it has applications that actually demonstrate all of the APIs that we have available on for Qt Embedded Enterprise. So whether this be a media player, Qt Quick Controls, just everything that's there. So that's what you get when you download, or when you get access to Qt Embedded Enterprise. And what you'll do is, when you actually get this package, you'll get an installer. And it's going to install. It's going to give you. It's the same installer you get whenever you get access to the embedded or the enterprise Qt, and you'll be able to check off that you actually want access to. If you have access to these devices, you'll just click I want Qt Embedded Enterprise for IMX6 Embedded Linux, and it'll actually download an image and a toolchain and a sysroot, and have all of this configured, and then you'll get some documentation that actually just tells you how to flash your device. So if you have one of the reference devices, say, even if we have, you say a Beagle board, it's just a matter of, okay, well, what you need to do to flash the SD card to boot the boot emulator. In this case, it's just one command of copying the file, or the file image for the SD card to the SD card, and then you just put the SD card into the device and boot it up. And as far as the device software goes, that's all you have to do. So once you're at that point, what you get is this Qt creator that's already configured to run for these devices. So in this case, I have a lot of these guys open already. But you just add these kits. So in Qt Creator, there's the concept of kits, which basically means target device, target OS. So if I create a new project here, let's just go ahead and do that. Qt Quick Application. And then when you get to the third screen, you actually select which kits you want available. And when you install a creator, you actually get a choice of what kits you want to download from the server. So in my case, I've actually picked Android, being the mobile Android itself, as well as many of the Qt or Qt Embedded Enterprise kits. So what we'll test with is we'll try the embedded Android emulator, and we'll do the embedded Android IMX6 kit. So now what this gives you is just a simple Hello World application. So I think we can, if I actually add a desktop, I think we can run it on the desktop first as well, just to see. I think that should be sufficient. And then we should be able to run this on the desktop. And you'll see here that in this case, it's just a simple Hello World application. And it's done completely in QML. You don't necessarily have to write your applications in QML. With Qt Enterprise Embedded, you can write your applications using the widgets API as well. In the case of this, in IMX6, we're able to use the full power of Qt 5. We're using OpenGLES 2. So by using Qt Quick 2, you're actually taking advantage of that support. So what I'm going to do is I'm just going to make this application a little bit more interesting by taking some pre-written code instead of just this simple hello world application that does nothing. This is a cute day 14. Yes, so we'll run it again on the desktop, and this is what our test application looks like. Pretend this is your amazing app that you wrote that you want to put on your hardware. So we want to run that on our device. So right now, there's nothing interesting running on the device, just the launcher. So if we want to run that on the device, it simply is selecting, this is an embedded Android image. We want to select the boot embedded Android IMX6 kit. We'll put it in release mode since we're not interested in debugging right now. And then it should be as simple as that. Let's see if it's building it. And there it is. So that's when you actually get the thing, or when you actually get your Qt Creator installed, the configuration for the devices is actually pre-configured into Creator. So you don't have to worry about manually setting up the kit, this kit installation, which again is a bit of an involved process and is totally doable, but in this case it's already done for you. So that is just running the software from this machine, cross-compiling the software from this machine, and then pushing it to that device and then running it. In addition to being able to run the software, you're also able to debug the software. So if we just say, for example, set a breakpoint in the C++ code, we're setting the breakpoint from the desktop machine. Switch it back to debug mode, of course. Then we should just be able to hit the start debugging button, and it should debug on the device. So you can see here it's actually loading the libraries into the debugger. Give it a minute because it's actually running over the network or over the USB cable. Oh, that's another important thing to, or an interesting thing. One of the trickier bits of embedded development is actually talking to your device. And one of the neat things about Android and iOS is that it's just a matter of hooking a USB cable up to your device and pushing to it. Well, we can do that too on embedded or Qt Embedded Enterprise. So only thing, I don't have any network cable, any serial cable hooked up to this guy. I just have the standard network cable, and we're just using ADB in the same way that the Android developers are. And this works both on Android and embedded Linux. Now that the library is actually loaded, we've actually broke into our application. So we're C++ debugging on the device. We have the stack trace. We have the, yeah, we can see the threads running. We can see the stack trace. Of course, we haven't done anything here, but we're able to actually stack and run on the device. I think we did something interesting there, but you're able to actually do that, and you can also do JavaScript or QML debugging as well. So in that same way, we should be able to run this, so we can run that same app again, and it should pause when we click the screen. I do believe that's what we've, so no, that's actually the text, so that's not going to do anything. If we put it here, it should. Check this breakpoint. But okay, so yeah. So it's stopped there again. Oh well. But so we're able to do that. So you're able to do C++ debugging, QML debugging, well, QML and JavaScript debugging. You're also able to do profiling. So you can actually profile on the device using Qt Creator as well. So to do that, we actually go to this Analyze tab. Close that right here. And then we just hit this play button for the analyzer here. So in this case, we're actually doing the QML profiling. So in this case, we're doing an animation of this text is growing and shrinking, but maybe we need to know like how that works on this guy. I think I hit the wrong button. I'll think about it. Oh, there we go. So then you can actually see the breakdown of each frame, and how much time it spent rendering what. And if a case of like, oh, you had a very large JavaScript block and you wanted to see how long that took to load and run, then this is the view that you'd actually see that in. And again, this is actually running on the device. So many of the things you're able to do for the desktop platforms now, you can now do for embedded development. Okay, and the last thing I want to show you demo-wise is the emulator. So say you don't actually have a IMX6 that you want to run, but you want to try this stuff out. So we actually have an emulator available. So you just switch to an emulator kit and hit this button right here. It's going to start up the emulator. This guy's getting in the way here. So it's actually booting the emulator now, and I'm actually running a test demo from earlier, but normally it also would boot up to the Qt Enterprise Embedded launch screen, and we can just as easily run that same demo app in our emulator now. So it should stop this app and then start our other app. Yep, there it is. So you'll be able to run this, and we have an emulator available for both embedded Android and embedded Linux. Another interesting thing about this is that you saw that when the emulator started up, that it had that pink app that was animating as well. So whenever you actually push software to the device, it then boots into that software from then on. Like, so when you pull the power on the device, it's actually going to start up to that example or whatever the code you last pushed to that device, because that is now the software of the device. You can always reset it back to the launcher or whatever you wanted, but the idea being that you want to get something working quick and you want to, that is the device. You are creating the software for the device, so that becomes it. So let's just close this out. Okay, let's see, let's go back to the presentation. Okay, so now that I've given you a good idea of what Qt Embedded Enterprise actually is, I want to give you a use case example, maybe push this idea of device creation. So my use case is what I'd like to call the superfluous synth. And superfluous synth is an idea for this hardware-software combination. It's a piano, a keyboard, a synthesizer that actually helps you learn how to play the piano visually. Like it has a piano, like I have here a USB MIDI controller. This is a small portable one, but it could just as easily be a full 88-key keyboard. And I envision this as a piece of a keyboard that has a LCD screen attached. And what the LCD screen will actually show you is what notes am I playing on the scale, do some chord recognition to actually show you what chord you're playing, and generally just be an aid to learning the piano. So I need software to actually synthesize the sounds that are being played by the keyboard, as well as actually do the visualization of the music being played. So when I actually went to implement this as a device, I needed some third-party dependencies, because obviously I don't want to have to write everything from scratch. So to actually do the synthesis of the sound, I used a third-party library called FluidSynth, and that way I can just feed it MIDI notes, or the actual note values of the keyboard, the note value as well as the pressure being pressed, and it will give me back PCM wave file data. And it also uses sound fonts, so I'm using a public domain sound font. And then to actually do the visualization of the notes, like actually draw the staves and show you the location of the note on the staves, I'm using a JavaScript library that was actually intended for an HTML5 application. So this is something that a library written completely in JavaScript that was intended to be run in the browser to display musical notation. I've actually taken that and, with only modifying 3 lines of the JavaScript code, was able to run it in Qt Quick 2 using the Canvas 2D API. So I'll show that in a little bit. But that's something pretty neat about this. As far as hardware goes, again, I'm using this USB MIDI controller. I have the same 7-inch capacitive LCD screen. And again, we'll have audio output to play the audio. And I decided to use the iMac6 for this. Since we're using Embedded Enterprise, I needed to decide whether I wanted to use Android or Linux. It turns out that the FluidSynth library itself has a glib2 dependency, which is somewhat troublesome on Android. I needed to make sure that the kernel, whether that be the Android derivative of this or the embedded Linux kernel, actually had support for MIDI input. In the case of the default kernel configurations, they both do. And then there's a difference in how you actually access audio, or the low-level part of the audio that you need to feed it the audio data on Android or Linux. So on Linux we use ALSA, and on Android we use OpenSL. Fortunately, since you're using Qt, there's a low latency audio API, and we take care of all those details for you. So I'm just using Qt. So it doesn't matter. In the end, I chose embedded Linux because the glib dependency was so troublesome. So as far as the actual implementation goes, I did this application as both a C++, all of the backend code is done in C++, so the actual audio processing, the audio synthesis is done in C++, and then that is exposed to the Qt context, and then all of the UI is done using Qt. So I can show you a bit of that code, since I have that open here. We'll just go over this fairly quickly. So, let's see, sources. Again, this is all C++ code where necessary, so you can see here that I just have a bunch of classes that I'm exposing to Qt, and that's how you do it without doing a plugin. You're just basically saying what your namespace is, how you're going to import it, and then what the name of the object will be. So every time I create a synth engine object in QML, it's actually creating a C++ QObject-based class that for every time I instantiate that class there. And so from C++, this synth engine actually is just a wrapper for FluidSynth. Basically, I start a FluidSynth object in C, and that's where I'm actually feeding the MIDI data to the synthesizer, and it just returns sound that I can play with Q sound effect. So if you actually look at the QML code, have it here, you can see, well, that's in main view actually now. You can see that we have this synth engine that actually starts the synth. So what I'll do is actually run this code on the iMac6. I need to actually start up the embedded Linux version since I have the Android version in here. I'll put the camera on so you can see that. Let's do that. So, sorry about the glare as well. It's a bit dark when it's starting up. So one of the things you'll notice is that it does take, I don't know, 20, 30 seconds to actually boot, but that's more of the generic nature of this. If you're actually productizing your product, you can get down to 3 to 5 seconds boot time if you really wanted to. Maybe even faster if you did some fancy tricks. But so this is the actual end application, I should say. So this is the splash screen, and while it's loading up the synthesizer itself, and when that's done, it'll actually go to this UI. You can see on this side we actually have the saves, and that, again, this is all done in Qt, but that's using the JavaScript library to actually draw that. And as I play the notes, not only do they play, but they're actually displaying on the stage. And if we click on the chord recognizer, then we're also able to show what notes being played, or what intervals being played, or even what is being played. So A minor in there. So again, this is the UI itself, and you're also able to select the instrument you want. So if you wanted to play a different instrument, you're able to select that from the UI as well. And so that's the actual application. And again, the QML code is, again, just exposing the C or C++ objects to the QML, and the QML is actually instantiating them, and they're bound to the UI there.
Hello?
So basically, as notes are played, I get a note value, and then I can pass it to both the synthesizer, the chord recognizer, and the visualizer, the note visualizer, in this case, the note viewer. So that's the basics of how this works. Okay, so we covered those things. Again, when you go to the next phase, so you have a prototype like this of just what the software will look like with some just loose hardware. Then you go to the productization phase where you actually turn this into something you can sell. In the case of this, one of the things that I want to do is, maybe get the latency down. So the time between when I press the button and when I play, I want it to be as low as possible. And to do that, you do something like have a real-time kernel. Obviously, I want to improve the design. I mean, this is a very developer. You can tell a developer's made this UI. You want to get a professional designer involved. And then maybe I also want to deploy this to mobile platforms like iPad or Android tablets. So I need a virtual keyboard so that they could play. And since it's a Qt app, it's going to run. So, and then since it's a learning tool, you also want to focus on that rhythm. So you give them a metronome as well built in, so it's playing while you're going. So that's basically it. That's I guess a demonstration of how this actually works. Maybe you have some questions now about this.
Hello. How can we download and install the Qt embedded? It's free. It's licenses, prices.
Oh, okay, so the Qt Enterprise Embedded is actually a product that Digia offers. It's a value-added thing. It's a package itself that was created. And so if you're actually interested in this, then you need to, with Qt Enterprise Embedded, you actually need to contact Digia to get access to this. We do have an evaluation available, though.
I would like to understand better the low level, what there is under the hood.
Okay.
From the Linux point of view, for example, are you using an existing distro like Yocto and Pocky, or
yes,
are you creating something customized?
Okay, so with regard to Yocto, we actually have we are using the meta layers for, in the case of, say for the IMX6, we use the Freescale meta. So we're just building a distro off of these various layers, and then we have an additional boot to Qt layer on the top that has our specialization, like the additional things we need for easy configuration, easy to talk, like for example ADB. We have Qt5 included in that, as well as the demos, and that's the thing. So we've added an additional meta layer, but we are using Yocto, at least on the embedded Linux side. On the embedded Android side, we have a different way of doing it. But.
And this meta layer is included into the Qt Enterprise? Yes,
so when you actually get a license for this, then you'll also actually get access to that additional meta layer, because you're obviously going to want to, when you start productizing, you're going to need to start modifying the image to specialize for your needs. So you'll have our additional meta layer as well to work with.
Any other question?
About the emulator, I haven't been able to understand if it is x86 emulation or maybe also ARM emulation.
Okay, So I can answer that question. So right now it is x86 only. So it's actually running a virtual machine that contains the system image, whether that be Android or embedded Linux. We have been investigating actually doing an ARM version as well, so that you can emulate the end environment. One of the tricky things there is actually the graphics. So we spend so much time rendering the graphics that we couldn't run on ARM. In the upcoming versions of Qt Embedded Enterprise, this will actually be resolved so that we'll have enough CPU power to move and have a proper ARM emulator as well. In the same way that you have a choice for, say, the Android emulator right now, you can either run an x86 image or an ARM image.
Thank you so much.
Hi. I'm curious about the real-time operating system support, if I know like XML is supported, and if I know application which has a real-time part and a user interface which is not real-time, then I through Qt creator if I can set this kind of behavior.
Okay, so Qt Enterprise Embedded does not actually support any of the real-time OSs. Qt itself does, but as part of this easy-to-use package right now, we just have embedded Linux and embedded Android available. Of course, you could use a real-time Linux kernel, but that's not the same as, say, the proper RTOSs. Yeah, and with regard to the UI not being real-time versus the OS being, I think generally with the RTOSs, you have to make a choice whether you're running in single process real-time mode or the mixed mode. So I'm not an expert on that though. So that is something that Digia can provide help with though. Just not me.
So you don't have a class interfacing to the eventual case real-time part.
I'm not entirely sure about that. That's there's a couple of guys in I think they're in Ulu that specialize in this. I'm more of an embedded Linux